Hello and welcome to our webinar session today. We're really happy that you're going to be joining us to talk about how to get started with a Raspberry Pi. So my name is James Robinson. I lead our face-to-face teacher training program in the UK called Pi Academy, and I'm here to talk you through a little bit about how you can get started with the Raspberry Pi. So we're going to start off with just going through the session aims. So we're going to switch to my slides and we're going to talk a little bit about session aims and what we hope to get out of this session today. Okay, so there's a few things we're going to learn about. First of all, we're going to talk a bit about the different models of Raspberry Pi computer, and we're going to address the question of what is a Raspberry Pi, because some people will be familiar and some people won't be. We're going to be connecting and booting a Raspberry Pi, and some of you will be joining in with us at home, so hopefully you'll be following along. And we're also going to talk a little bit about, and perhaps demonstrate if we get time, some alternative ways to connect and control your Raspberry Pi. So let's delve into that now. I want to just also say a special welcome to anyone that's joining us from our FutureLearn course, and also point out to anyone that is joining us who doesn't know about our FutureLearn course that right now we have a Teaching Physical Computing with Raspberry Pi and Python course running. It's a free online course, and you can take part in that and find out about it at rpf.io/train-online. And one of the first things you do in that course is set up a Raspberry Pi, and so lots of our FutureLearn participants are hopefully joining us today to find out a bit more about how to do that. If you're participating in today's session, you're going to need a few things if you want to fully participate. First, you're going to need a Raspberry Pi. Next, you're going to need a keyboard and a mouse. The next thing you're going to need is some kind of screen or output. So we've got a monitor shown there. And then you're going to need a micro SD card. And your micro SD card, often these come with your Raspberry Pi, depending on when you've bought them. Or you can use any micro SD card that you might have lying around the house from a digital camera and so on. And then finally, the last thing we're going to need is a power supply. And the power supply is a micro USB adapter. That's the kind of adapter you would find in lots of Android phones. We have a recommended adapter for the Pi that gives it just the right amount of power, but most phone chargers will be sufficient. So we're going to look at how we connect all those things together and how we get started. There's lots of ways of participating today. Firstly, we're trying something called a Flipgrid. Now, many of our educators in the US will be aware of Flipgrid and how this works. But the idea is that if you go to that URL, or you can load the app, and you go to our grid, which has a code of 111264, you can leave a little video reply telling us a bit about who you are, where you're from, and why you're participating in this session. That might be something you do right now. It might be something you do when the session's ended. And that's just a way of us gauging how many people are taking part. Also, we'll be looking at the YouTube chat window, and my colleagues are going to be in there looking at your comments, your questions. We can see already lots of people are talking and hopefully helping each other out. But if you have any questions, ask them. And if we have some time during the session, we will try to answer as many of those as possible. And finally, join the conversation on Twitter with our hashtag RPILearn. And you can follow along there, and after the session, once our session's closed, you might want to move the conversation, if there's still conversation happening, onto that Twitter hashtag. So, the question that we're going to try and answer first of all is, what is a Raspberry Pi? And we go to lots of events and talk to lots of people, and this is a question that we often get asked. It's a very interesting, quirky name, and people don't quite necessarily understand what it is all about. So we're going to have a look at a few different Raspberry Pis and talk a bit about what they are. So we're going to switch to the camera now, and you can see here that we've got 3 versions of the Raspberry Pi. This is the one that we're going to be booting up today, this one here. This is the latest version of the Raspberry Pi, the flagship model. This is a Raspberry Pi 3. And this is the main one, and we've got an older variant of the Raspberry Pi. This is called an A+, and you'll notice there are some similarities and there are some differences. And then we're going to go to the smallest member of the Raspberry Pi family, this one here, which is our Raspberry Pi Zero. Now, all 3 of these devices are all Raspberry Pis. They are all computers in their own right. Unlike other devices you might find out there, these are not peripherals. These are fully fledged computers. We can use them as a desktop computer, and we're going to show that during this session. You'll notice there's a few similarities and differences. Let's look at some of these in more detail. So on our Raspberry Pi here, we have some connectors. We have 4 USB ports for plugging in keyboards, mice, memory sticks, and so on. We have an Ethernet port for connecting up to the internet. We have on this side, we have a HDMI port for connecting up our monitor. We have a headphone jack. Here is our power sockets, which you might just about be able to see there. And we've also got, and we'll talk about these briefly, here and here, we have 2 connectors for other peripherals, which we'll talk about in a moment. And finally, the other common thing that all of these have is this slot. This slot here, which is where our SD card goes. And we'll talk a bit more about the SD card and what role that plays in the Raspberry Pi in a moment. You'll find that on all of the devices. So you can see here it is on the A+, and on the Zero, it's actually on the top side just here. And the other thing, which make these stand out from other computers, but also is the thing that's common to all of them, is this bank of pins here, here, and here. Okay. So on the Raspberry Pi, we have these pins, and you can probably just about see those when I hold that up there. We have 2 rows of 20 pins, giving us 40 pins altogether. And these are our general purpose input-output, or GPIO pins. And what these allow us to do, if I just move these 2 to one side for a moment, is I can use cables and circuitry to connect up to my Raspberry Pi. So I can do that. This, is going to be connected off to a circuit over here. But I can connect up components up to my Raspberry Pi. I can build circuits, and I can control elements from my Raspberry Pi, writing instructions on the Raspberry Pi which drive the physical elements in the real world. So that's one really unique and special feature of the Raspberry Pi. And one of the things which I didn't mention at the very beginning, and I probably should have done, was one of the reasons that we think these are really useful, particularly in education. This computer, the Raspberry Pi 3, costs $35. And you can get these all over the world. And what we really hope is that this sort of turns computing into a material. I can take this, I can use it in the classroom, I can use it with my learners, I can embed it in projects, I can create with it. And then if I break it, if I need to do something else, then actually the cost of replacing this unit is not significant. But for some people, $35 is still a significant proposition, and so that's one of the reasons that we created the Raspberry Pi Zero, which we just lost the focus on there. So I'm just going to try and find the focal point there. There we are. And this Zero is it's a little bit less powerful, but it's much smaller. And this you can get for I think it's around £10 at the moment. That kind of price. Okay. Depending on which version you go for. Some versions have Wi-Fi on board, some have the camera, some don't. But we recently gave some of these away for, you can get this for $5. We gave some away free on Clever magazine a few years ago. So this is a very low cost option and is a very nice option for some people. So we'll talk about these in a bit more depth later on. We've mentioned the pins, and if wires and circuitry aren't the kind of things that you want to be doing with your learners, there are other ways to engage in physical computing. This is a hat. This is a board which sits on top of the Raspberry Pi pins like that. We slide it down onto the pins. I've got a bent pin there. And this is called the Sense Hat. And the Sense Hat, as the name suggests, has a load of sensors on board. It's also got all of these LEDs, and we can do really interesting, fun, engaging projects with that. We also have, try and take that off without bending more pins. There we are. Just take that off as well. Right. There are also other additional peripherals you can add. So here I have this camera. So this camera module is basically, it's a camera from a mobile phone on a little circuit board. And you can connect this up to this connector that I sort of pointed out earlier on. Pop it in there, and you can write code that takes pictures from your Raspberry Pi. And there's a second one here which allows us to control a screen. So the very final thing which we should mention in order to use this, we need one of these. We need an SD card. And the reason for that is this piece of hardware over here is simply that. It's a piece of hardware. It can do nothing without instructions, without software. This is stupid. This is the thing that gives it intelligence. Okay, so what we can do is, or a function rather than intelligence, perhaps not implying that the computer is sentient. So we can take this SD card, this micro SD card, which comes out of the SD card slot, and we can insert that into our Raspberry Pi. And that's the software that our Pi is going to run. And we're going to have a look at that software in just a moment. But first of all, perhaps let's have a think about how we might get hold of the software that's on this SD card. And for that, we're going to switch back to one of our slides, and I'm just going to talk you through a couple of different options on how to get hold of this card. So we've answered the question, hopefully, what is a Raspberry Pi? And the software that we're going to use is called Raspbian. And Raspbian you can get hold of Raspbian in 3 different ways. The first, and probably the easiest way to get hold of Raspbian, is to buy an SD card with Raspbian pre-installed. Lots of vendors that sell this around the world so give you this option when you purchase your Raspberry Pi. Your SD card comes with it. One slight downside of this is that it's possible, depending on when you buy your SD card, that you might miss out on an update from the Raspberry Pi Foundation and your software may become outdated. The second option, and the one that I think most people should at least try and have a go at, is flashing your own SD card. And we're going to drill into that a little bit in more detail in just a second. It allows you to get the latest software from the Raspberry Pi Foundation and reuse existing SD cards that you might have around the house. It also means that if you completely mess up the software on your Raspberry Pi, you accidentally delete everything, you can reflash your SD card without having to go back and buy a new one. And what it does, you do need a computer and some flashing software to do this, but that's a fairly low barrier to entry. And the third option, which has some unique features, is something called Noobs. And this is something you can do from the Raspberry Pi website. This allows a little bit more control. You can install multiple operating systems on-site along one card. You can also add some recovery options to your SD card as well. The downside of this is it's very quick to make the card, but the first time you boot it up, it will take some time. So they're the 3 ways that you can get an SD card. And I would recommend for most people, this is the option that most people want to be doing most of the time. This is good when you're starting out. This is great if you want to repurpose an old SD card or update your software. And this is useful if you want to be doing something with multiple OSs. So how do we flash Raspbian, which is something we often talk about? Well, it's really very simple once you've got the hang of it. First of all, you go to the Raspberry Pi website, and you can use the link at the bottom there to get hold of a copy of our Raspbian desktop software. You download the zip, put it onto your computer, and then you use this piece of software called Etcher, which makes it really easy. You select the image, select the drive, click on flash, and it will sit there and burn your image. It will take about 20 minutes, and once it's burnt, it'll be ready or flashed, it'll be ready to go, and your Pi will be ready to boot. If you want to spend a bit more time looking into that in more detail, we have a fantastic video by Lucy, the editor of the Magpie magazine, who talks you through that in much more detail than I can now, step by step. There's a link at the bottom of this page, and we're going to share all of these links and lots more information at the end of the YouTube video. So that's a really useful video to sort of help you through that step by step if you want to go and do that. So let's go and set our Raspberry Pi up. So we're going to switch back to the camera now. Okay, so we can see our Raspberry Pi. And when we're setting up our Raspberry Pi, there is a particular sequence or order that we want to do this in. And the most important thing to remember is our power lead here is the very last thing that we're going to connect. So I'm going to put that to one side for the moment. So first of all, I'm going to bring over my USB keyboard and my mouse. Bring that over as well. Pop that in. Okay. And then what I'm going to do is I'm going to bring over my HDMI lead. My HDMI lead is going to connect me up to my monitor. And the final thing, now I've already done this, but I should also be making sure that my SD card is connected up as well. So what we're going to do is in a second, I'm going to plug this in and we're going to see the Raspberry Pi boot. what we're going to do is we're just going to switch to the display for the Raspberry Pi so that we can see that. So let's just do that now. Let's switch over. So I think if we go now, if we plug this in, we should. There we go. So we get the lovely rainbow splash screen. We can see our 4 raspberries, which is telling us that the Raspberry Pi is starting to load. It's then giving us a little splash screen as it boots up. And after a few seconds, we end up in the desktop environment. There we go. Okay, so this is our desktop environment. And I've got a message that's appeared there because I was playing around before this session and I've turned on a setting which is a bit insecure. So I'm going to just go and turn that off now. I'm going to try and do that anyway. There we go. Okay. I should point out that as I'm using this, I am looking very helpfully at a mirror image of the Raspberry Pi. So if I look like I've never used a mouse before, that is the reason. So I'm going to try and do this as best I can. And we're going to try and do a little bit of a demonstration of how the Raspberry Pi works and a bit of a tour of the software. So all of the software you see that we're going to look at, it all comes as part of the Raspberry Pi operating system. It's all free. A lot of it's open source, and we provide it for your use for learning and learning about digital making. So one of the first things we're going to do is I'm going to go over here, and I'm going to say, like, one of the first things we probably want to do is connect up to the Wi-Fi. And to do this, we would go up to this icon here. Now, unfortunately, I can't quite see my Wi-Fi in this room, but you should see a list of Wi-Fi available Wi-Fi networks in there. You'll click on the Wi-Fi network, and you will then go ahead and you'll be connected up to the Wi-Fi. You'll be asked to enter your password, just as you would normally. What we're going to do is, while I'm talking, we're going to see if we can get onto the Ethernet with the Raspberry Pi, so that we can show some of the stuff later on. So what we're going to do is I'm going to show you some of the things we can do with the Raspberry Pi. So first of all, one of the really useful sort of points to note is that if we go in here to our menu and we go down to Internet, when you are connected up to the Raspberry Pi, you can click on the Raspberry Pi resources, and what that will do is it will connect you up to our website, and it will give you access to our resources. So hopefully we are now connected, and we're going to see that happen. And all of the resources that we're going to see here they're free, they are Creative Commons, and I've got an error message there that I can't quite tell what's going on, particularly as I am now backwards. So trust me, you will see the Raspberry Pi resources there, and that's a really helpful thing. You can go onto there, you can see the resources, all of them are free. There's loads of great projects on there for you to engage with and learn from. One of the other really important things is that on the Raspberry Pi, we have a whole load of software available for you to use for programming. So if you're a beginner programmer, we have Scratch and Scratch 2 available for you to use. So this is a block-based environment. You can drag together blocks to create programs and build sort of interactive games and animations and so on. Lots of younger children will be familiar with Scratch. Many learners then progress onto a text-based language. Lots of people jump to Python as their next phase, and Python's a really powerful language for allowing users to progress onto a text-based language. We have both Python 2 and Python 3 available. If you're looking for a slightly different route to transitioning to a text-based language and a really engaging route, have a look at Sonic Pi. Sonic Pi is a fantastic piece of software that allows you to use Ruby code to generate sounds, music, and compositions and performance. And this has been developed alongside teachers in the classroom and a developer called Sam Aaron. And this piece of software is absolutely fantastic. I've used this with my students, and it's a really nice kind of in-between phase between block-based programming and text-based programming. It takes a lot of the lessons from Scratch and implements them in a text-based way. And then if you're looking at Java, we have things like Greenfoot and BlueJ, and we have a multitude of different editors on here. And if you want to use the SenseApt, which we talked about a bit earlier on, the SenseApt emulator is here, so you can play around with the SenseApt without access to the actual physical hardware. So that is kind of a real whistle-stop tour of some of the hardware and software that is available from the Raspberry Pi. And so within the software, you've got lots of programming options, but we're going to just talk about a couple of other things in there as well. First of all, configuration. So configuration is really important. There are times when you want to turn on or off some different options in your Raspberry Pi. So for example, if we just go to the Raspberry Pi configuration menu here, there are times where you will want to be able to use the camera. And as you can see here, I've already gone in and I've enabled that camera port that I pointed out to you earlier on the Raspberry Pi. By default, it will be disabled. I've also enabled SSH and VNC. And depending on what hardware and other things you're using, you may want to enable things like I2C, SPI, a serial interface, remote pins, and a variety of other options. You'll also find other options in here about the name of your Raspberry Pi, how it boots, and so on. There's lots of really powerful options for configuring your Raspberry Pi in there. And you can also make, sort of cosmetic changes. You can change your desktop background and so on. All that kind of stuff can be done as well. And it's important to note that this is a full operating system. This is a computer. So as well as all these programming tools, we have an Office suite. So we've got a word processor, we have a spreadsheet, we have a presentation creation tool. It also comes with a set of games. So Minecraft Pi is a programmable version of Minecraft. And so there's a whole suite of tools on here that make this just a regular computer that happens to be cheap, that happens to allow us to connect to real life hardware. We talked very briefly earlier on about your software potentially becoming out of date. And one way that, the way to avoid that is to follow our update procedure. Now, the update procedure is usually done from this terminal screen. And the terminal screen is a really powerful interface to interact with our Raspberry Pi. It allows us to talk to the computer using text, and we haven't got to use this annoying mouse. So I'm going to be much better at this because I haven't got to look at this in mirror image. So there are two commands we need to update our Raspberry Pi, and we'll see if they work on this internet connection that we're on at the moment. The first one is going to look at the internet, look at our repositories of software, and find out which things have been updated. And so the command we type is sudo, which gives our user, temporarily gives us administrator rights to carry this out. And we can type apt-get, is what a lot of tutorials will show you, but you can actually just type apt. And we're going to run the update process. And hopefully, if we've got a decent connection, it looks like, yep, that's going off. It's talking to lots of web servers, and it's finding out what packages are currently available that we haven't got already. And that's going to spend a few moments doing that. And so all of these packages, you can install extra packages as well. All of these repositories are maintained by the Raspberry Pi Foundation and its community. So that has now gone away, and it's found out what new software is available. The next command is sudo apt-get, remembering that we can just type apt if we want to. And the next command is upgrade. And what upgrade will do is it will look at any packages that you have installed. And for every package that has a potential update available, it will go away and it will fetch that update and it will install that package. And if I hit enter on that, that's going to sit there and it's going to ask me, here's all the stuff you need to update that's out of date. Would you like to proceed? You'll hit yes, you'll press enter, you'll wait for a period of time, and it will be updated. I'm not going to update at this point, and I'm going to press no. So the terminal is a really powerful way to interact with our Raspberry Pi. And I mean, just because we've got a few moments while we're here as well, I'm just going to show really quickly a couple of other things. We can find all of the files and things we're working on our Raspberry Pi in the file manager, just as you would in a Windows or Mac machine. And we can see here that at the moment I'm in the Pi's user folder. So within the Pi's user folder, I have a desktop folder, I have documents and so on. This is basically the equivalent of my documents on a Windows PC. Okay? So, and there's lots of more things that we could explore, but we're going to move on from that for now. One thing to note is that lots of the things we're talking about in this video, we have tutorials and guides for on our website or on YouTube. And in particular, the update process that we went through here is covered in a YouTube video that you will find on our YouTube channel. So the very last thing we're going to do is we are going to shut down our Raspberry Pi. And this is really, really important that we as users, and if we're working with learners, we encourage them to do the same thing. If the Raspberry Pi is, as it is now, idle, if we unplugged the power, we would probably be fine. I mean, we're probably not likely to have any file corruption. However, it's always good practice to shut our Raspberry Pi down carefully and properly. So from the menu, we can select shut down. That will pop up a little menu, and we can either shut down, restart, or log out. What I'm going to do, however, is I'm going to look a little bit cool. I'm going to do it from the terminal, so I can type sudo, which, if you remember, that's going to give me administrative privileges, and I'm going to type halt. And then what we'll do is, in a second, we're going to have a look. Well, we'll shut this down, and our Pi is going to shut down. And then if we look at the Raspberry Pi, we can see that the green light is flickering, and now it's off. When that green light just there, I don't know if you can see that on the screen, when the green light has gone off, your Pi is now shut down. The red light remains on as it is still receiving power from the USB power lead. And that red light will stay on, but the computer's not doing anything. If I were to unplug it, that's now off and shut down and powered down completely. And then the moment I plug that back in, my Raspberry Pi would reboot, and I will start to see that I've got this LED, this green LED flickering just here. That green LED shows activity on the Raspberry Pi. So that covers a number of ways of us using the Raspberry Pi. We've talked about some of the software we'll find on it. We've talked about some of the hardware that we can attach to it. We've talked about a whole range of different things. What we're going to have a really brief look at now is that the setup we've used there with keyboard, mouse, monitor, and power is not necessarily something that everyone's going to have access to. And so there are some other ways that we can connect to our Raspberry Pi and control it. So we're going to go to the presentation slides, and we're going to have a look at a couple of those options. So let's just switch over to the presentation again, which I need to do on my computer. So just give me a second. Smoothly done. There we go. Okay, so there's a couple of different alternative methods. So this one here, this is something called SSH. Now, you might have remembered that on the Raspberry Pi in the configuration menu, there was the option to enable SSH. And what we can see here, what you're seeing in the picture there is this is a window on my laptop, and I've connected over the Ethernet that I'm connected to up to the Raspberry Pi. And you can see here, if I just point this out here, you can see that I'm actually on the Raspberry Pi, but I'm viewing the output from the Raspberry Pi on my laptop device. This is a really powerful way of connecting to our Raspberry Pi. I'm not sure who's been using this particular Raspberry Pi, but we can see there's a whole load of weird file names there, Selfinator, lol, and so on. But these are all files existing on that Raspberry Pi, and I can talk to that via this text interface, and I can do lots of really powerful things that way. But sometimes you might want to interact in a graphical way. And for that, we can use something called VNC. And VNC is a piece of software which comes by default with the Raspberry operating system. And you can connect your Raspberry Pi over the internet using a graphical interface instead. So here what you can see is the Raspberry Pi window, the desktop, sitting in a window on my desktop, and I can use my computer's mouse to control the virtual mouse on the Raspberry Pi. So I can interact with the Raspberry Pi over this screen. And you can find out more about how to do that at the link there, rpf.io VNC. And that will talk you through how to set that up. And then the final thing we're going to talk about, and we're going to try and demo, but what with the curse of live demos, with this may or may not work. But it does work. It worked out on my desk. We'll see how it goes. What we can do is we can actually use that Pi Zero that we talked about earlier on. We can connect it up to our laptop or another computer. When we plug it in, we get this option of it being a GPIO expansion board. We can then write Python or Scratch programs on our laptop that will control the LEDs on our Pi Zero. You'll notice here that this Pi Zero does not have an SD card plugged in. It simply has one data cable that is also providing power, and this is enough to make this work. So we're going to try and have a look at that and see if we can demonstrate that. We'll see if we have any success with that or not. So what we're going to do is we're going to have a look at a laptop that I've got set up just here. So we're going to switch over to another camera. Okay, so you can see here that we have this laptop set up. Oh, there we go. Okay, so the camera's a little bit jumpy there. There we go. So we have this laptop set up, and what I'm going to do is just show you that I've got here a Raspberry Pi Zero, and just to illustrate, there is no SD card in this Pi Zero. So there's no software being run on this Pi Zero. If I were to take I'm going to take this little board here and I'm going to pop it on, and I've forgotten which way to connect it, so I think it is down here. So I'm going to pop this connector on. So I've got this little traffic light thing that I've set up. So I've got this little traffic light Pi stop. It's on my GPIO pins. And then using a USB wire, which we can find over here, I'm going to plug in to the data connection, or USB connector on my Raspberry Pi, like that. And then when I connect that up to my Raspberry Pi, to my computer, sorry, when I connect my Raspberry Pi to my laptop, on my laptop, I will get this little window, which you probably can't see particularly clearly where you are now. But we can see how I've got three options. And the first one is GPIO expansion board. And if we click on OK on that, what it's going to do is it's going to sit there and it's going to install or run a little bit of software for the Raspberry Pi. And my Raspberry Pi is now booting and connecting up to the laptop. There we are. That's now done. And then what I can do, and we'll see if this works. It worked earlier on. Okay, is we are gonna. I'm just gonna open up a little terminal like this, and I'm gonna try, and we'll see. I'm going to try and run a little Python program. Again, you can't see what I'm demonstrating here, which is a bit unfortunate, but we'll see how we get on. If we get some light, we get some light. So we're going to do GPIO 0. I'm going to import an LED. So from GPIO 0, I'm going to import an LED. So this is working with the GPIO 0 library, which was created by Ben Nuttall and is one part of the libraries that ship with the Raspberry Pi. We're going to create an LED object, and I'm going to say that that is on, let's just do this. I'm trying to do this one-handed. I'm going to say that that's on pin 13, and then I'm going to try and do, fingers crossed everybody, let's see if this works. I'm going to do LED on, and I've probably done something wrong here, but we'll give it a go. Yay, we've got a little light. I don't know if you can see that, but we've got a little light up here on my traffic lights, and if I were just to make that a bit more obvious, I could say LED dot blink, and I'm going to give it some time parameters. Okay, and if I do that, then you can see here my LED is blinking, and there we go. So what I've done here is I've booted up my laptop using a version of Raspbian for the desktop. But you could do this on any version of Linux, and we're hoping that other versions will come for other platforms later. And the idea is that now I don't need an extra keyboard, screen, and mouse. I can drive my Raspberry Pi directly from my laptop, which is fantastic. So what we'll do now is we're gonna switch back to our slides, and I'm going to try and reposition this camera. We're going to just sort of wrap up this session now, because I think we've spent a fair bit of time looking at a number of different ways of controlling and interacting with the Raspberry Pi, and we've had some successes. We've had a couple of issues, but let's just summarize what we've talked about over the course of this session. So first of all, we've hopefully demystified a little bit of what the Raspberry Pi is. It is just a computer, and yes, it's small and it's low cost, but it's just a computer. What makes it slightly special is the fact that it can do this hardware interaction stuff, and it can do that at a really great value, low cost price point, which makes computing and programming and digital making more accessible to more people. So we can connect hardware and components to allow it to interact with the real world. And finally, the Raspberry Pi runs a free operating system. And that free operating system, Raspbian, is available from our website. We maintain it and update it. And you can download that at any point and update it once it's on your Raspberry Pi. And something which we didn't get really, or weren't able to show you because of our internet connection here for some reason, was our resources. So the resources are absolutely fantastic, and there are loads of them on our website. And you can find those if you go to this link up here at the top, and we'll include it in the comments, rpf.io/learn. You will see our around 200 projects that we have, some of them using the Raspberry Pi, but many of them not. And they're suitable for a whole range of experience levels, all the way from beginner to people that have had loads of programming experience before. And so all that remains, I think, is for me to say thank you for participating. I think we haven't got a huge amount of time for questions, but if you ask any questions in the YouTube chat or on Twitter, we'll address some of those in there. Finally, I want to share with you our next session. So our next session we're going to be running is called Moving from Blocks to Text. And the focus of this is going to be all about how we transition from Scratch and Blockly and those kind of languages to something like Python, SonicPy, text-based languages. And this is going to link up with one of our Future Learn courses that we are launching soon, and we're hoping that we can engage people with those activities through that webinar. So I hope you can join us. What we'll do is we will share out the link for registering for that shortly, and we hope that you can join us for that, our next session. And then finally, feedback. We really, really value your feedback, and I'm going to labour this point very slightly before I sign off. Your feedback's really, really helpful for us. This is our first public webinar that we've done, and we're really hoping to do more and more of these. We will send a document containing all of the links to all the things we've talked about in this webinar to everybody that gives us feedback via that link. So if you send that feedback to us, let us know what you thought about this session, how it could be improved, what else we could be doing. And then early next week, you will get a link to a document that talks you through everything we've talked about in this session with much more detail. Okay, thank you very much for joining us for today's online video session. We hope you've had an enjoyable time. Don't forget to ask any questions in the YouTube comments. Give us a little introduction on Flipgrid, and we'll see you next time for Blocks to Text. Thank you very much. Bye-bye.